Chemistry in everyday life. By now, you have learned the basic principle of chemistry and has realized that it influences every sphere of human life. The principle of chemistry has been used with benefit for the mankind. Think of cleanliness, the materials like soap, detergent, household bleaches, toothpaste, etc. will come to your mind. Look towards the beautiful cloth. Immediately, chemicals of the synthetic fibers used for making cloth and chemical giving colors to them will come to your mind. Food materials again, a number of chemicals about which you have learned in the previous unit will appear in your mind. Of course, sickness and diseases reminds of medicines again chemicals. Explosives, rocket propellants, buildings and electronics materials are all chemicals. Chemistry has influence in our life so much that we cannot even realize that we come across chemicals at every moment. That we ourselves are beautiful and chemical creations, and all our activities are controlled by chemicals. In this unit, we shall learn the application of chemical in three important interesting areas, namely medicines, food materials, and cleansing agents. Drugs. Drugs are chemicals of low molecular mass, 100 to 500 mu. These interact with macromolecules, target and produce a biological response. When the biological response is therapeutic and useful, these chemicals are known as medicines and is used in diagnosis, prevention, and treatment of disease. Most of the drugs used as medicines and potentially poison, even if the dose higher than the recommended use of chemicals for therapeutic effect is chemotherapy. Chemotherapy. Classification of drugs. Drugs can be classified mainly on criteria outlined as follows. On the basis of pharmacological effect, the classification is based on pharmacological effects of the drugs. It is used for doctor because it provides them the whole range of drugs available for the treatment of a particular type of problem. For example, analgesic have pain-killing effect. Antisepticals or arrest the growth of microorganisms. On the basis of drug action, it is based on the action of drug on a particular biochemical process. For example, all antihistamines inhibit the action of the compound. Histamine causes inflammation of the body. There are various ways in which action of histamines can be. You will learn about this in section 16.3.2. On the basis of chemical structures, it is based on the chemical structures of the drug classified in this way. Their common features and have often similar pharmacological activities. For example, sulfonamides have common structures given below. On the basis of molecular targets, drugs usually interact with biomolecules such as carbohydrate, lipids, protein, and nucleic acids. These are called target molecules or drugs target. Drugs possess some common structures features may have the same mechanism of action on targets. The classification based on molecular target is the most useful classification for medical chemist. The classification based on molecular targets is the most useful classification for medical chemist. Drug target interaction. Macromolecules or biological origin perform various functions in the body. For example, protein, which performs the role of biological catalyst in the body, is called enzymes. Those those which are crucial to communication system are called receptors. Those which are crucial for communication in the body, receptors. Carrier proteins carry polar molecules across the membrane. Nucleic acids have the coded genetic information for the cell. Lipids and carbohydrate are the structural part of cell membrane. We shall explain the drug target interaction with the example of enzyme and receptor. Catalytic action of enzyme. Catalytic enzyme action of enzyme. For understanding the interaction between a drug and an enzyme, it is important to know how do enzyme catalyze the reactions. In this catalytic activity, enzymes perform two major functions. The first function of the enzyme is to hold the substrate for a chemical reaction. The first function of an enzyme is to hold the substrate for a chemical reaction. Active sites of enzymes hold the substrate molecules in a suitable position, so it can be attached by the reagent efficiently. Substrate bind to the active site of the enzyme through a variety of interactions such as ionic bonding, hydrogen bonding, van der Waals interaction, or dipole-dipole interaction. This is the active site, this is substrate, and this is enzyme holding substrate. The second function of an enzyme is to provide functional group that will attack the substrate and carry out a chemical reaction. Drug enzyme interaction. Drug inhibit any of the above mentioned activity of enzyme. These can block the binding site of the enzyme and prevent binding of the substrate on can inhibit the catalytic enzyme of the catalytic activity of the enzyme. Such drugs are called enzyme inhibitors. Drug inhibit the attachment of substance on active site of enzyme into different base. Drug compete with the natural substrate for the attachment of the active sites. Such drugs are called competitive inhibitor. This is an active site. These are drugs, and this is substrate. Drugs compete, they cannot enter. Some drugs do not bind to the enzyme site. These bind to a different site of enzyme, which is allotropic site. The binding of inhibitor at an allotropic site changes the shape of the active site in such a way that a substrate cannot recognize it. If the bond formed between the enzyme and the inhibitor is strong covalent bond and cannot be broken easily, the enzyme is get blocked permanently. The body then degrades the enzyme inhibitor complex and synthesize the new enzyme. Receptors as drug target. Receptors as drug targets. Receptors are proteins that are crucial to the body's communication process. Majority of these are embedded in the cell membrane. Receptor proteins are embedded in the cell membrane in such a way that the small part processing active site projects out of the surface of the membrane and open out on the outside region of the cell membrane. Receptor proteins are embedded in the cell membrane in such a way that the small part processing active site projects out of the surface of the membrane and open outside region of the cell membrane. Small part of cell membrane, outer cell membrane, interior cell membrane, animal cell. In the body, message between two neuron. In the body, message between two neuron and that between neuron to muscle is communicated through certain chemicals. These chemicals are known as chemical messengers and received at the binding site of receptors protein. To accommodate a messenger, shape of the receptor site changes. This brings about the transfer of message into the cell. Thus, chemical messenger give message to the cell without entering to the cell. This brings about the transfer of message into the cell. The receptor receiving the chemical messenger. First case, shape of second case, shape of the receptor changes after attachment. This shape is changed, and receptor regains a structure after removal. It again comes to previous one. There are a large number of different receptors in the body that interact with different chemical messenger. These receptors show selectivity for one chemical messenger over the other because their binding sites have different shapes, structures, and amino acid composition. Drugs that bind to the receptor site and inhibit its natural function are called antagonistic. These are useful when blocking of message is required. There are other type of drug that mimics the natural messenger by switching on the receptor. These are called agnostic. These are useful when there is a lack of natural chemical messenger. In this section, we shall discuss the therapeutic action of few important classes of drugs. Antacids. Antacids. Overproduction of acid in the stomach causes irritation and pain. In severe cases, ulcers are produced in the stomach. Until 1917, only treatment for acidity was administration of antacids such as sodium hydrocarbonate or the mixture of ammonium and magnesium hydroxide. Antacids such as sodium hydroxide, mixture of ammonium and magnesium hydroxide. However, excessive hydrocarbon can make a stomach alkaline and trigger the production of even more acid. Metal hydroxide are better alternatives because of being insoluble. They do not increase the pH above neutrality. These treatments control only symptoms and not the cause. Therefore, with these metal salts, only symptoms and treated easily. In the advanced stage, ulcer become life-threatening, and its only treatment is the removal of affected part of the stomach. A major breakthrough in the treatment of hyperacidity came through the discovery according to which a chemical histamine stimulates the secretion of pepsin and hydrochloric acid in the stomach. The drug, the drug cimetidine, which is also known as tegament, was designed to prevent the interaction of histamine with the receptors present in the stomach bar. This resulted in release of lesser amount of acid. The, the importance of the drug was so much that it remained the largest selling drugs in the world until another drug, ranitidine, which is Jantac, was discovered. These two are drugs name. Histamine, histamine, cimetidine, ranitidine. Antihistamines. Histamine is a potent vasodilator. Histamine is a potent vasodilator. Vasodilator means dilation of blood vessels. It has various functions. It contracts the smooth muscles in the bronchi and gut and relaxes other muscles, such as those in the wall of fine blood vessels. Histamine is also responsible for the nasal congestion and associated with common cold and allergic response to pollen. Responsible for nasal congestion associated with common cold and allergic response to pollen. Synthetic drugs, brompheniramine, Temetab, terfenadine, Seldane act as antihistamines. They interfere with the natural action of histamine by competing with histamine for the binding site of the receptor where histamine exerts its effect. Now the question that rises is why do above mentioned antihistamines not affect the secretion of acid in stomach? The reason is that the anti-allergic and anti-acid drugs works on different receptors. The reason is anti-allergic and anti-acid drugs work on different receptors. Neurologically active drug, tranquilizer. What is this? This is tranquilizer. Tranquilizers and analgesic are neurologically active drugs. These affect the message transfer mechanism from the nerves to receptor. This compose our nervous system, nerves to receptor. Tranquilizer are a class of chemical compound used for the treatment of stress, mild or even more mental diseases. These relieve anxiety, stress, irritability, excitement by inducing a sense of well-being. They form an essential component of sleeping pills. There are various types of tranquilizer. The function of different mechanism. They function by different mechanism. For example, noradrenaline. Noradrenaline is one of the neurotransmitter that plays a role in mood changes. If the level of noradrenaline is low for some reason, then the signal sending activities become low and the person suffers from depression. In such situation, antidepressant drugs are required. These drugs inhibit the enzyme, which these drugs inhibit the enzyme which catalyze the degradation of noradrenaline. If the enzyme is inhibited, this important neurotransmitter is slowly metabolized and can activate its receptor for a longer period of time, thus counteracting the effect of depression. Epronogide and phelanigide are the two such drugs, which are antidepressant. These two drugs are antidepressant. Some tranquilizer, namely chlor CH chlordiazepoxide, 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 and meprobamate. Meprobamate. Meprobamate are relatively mild tranquilizers suitable for relieving tensions. Equanil is used to controlling depressions and hypertension. Chlordiazepoxide, meprobamate, equanil. Derivative of baributic acid. Vinyl